The animal kingdom. It's one of the natural world's most impressive feats, creating some truly awe-inspiring behemoths over the last several hundred million years. However, as with everything great, the animal kingdom didn't just pop into existence overnight with the first stegosaurs and T-Rexes and elephants. Instead, the evolution of animals, as with all life on Earth, was gradual. And this means a simple truth. At one point, hundreds of millions of years ago, there had to have been a species that was the first animal. Well, we'll be turning back the clock to explore the world around 700 million years ago to answer once and for all, what was the world's first early animal that evolved? If we're going to answer this question, probably the first thing we need to look at is, where did the world's earliest animals come from anyway? Well, it's currently proposed that the animal kingdom evolved in the Ediacaran period from protists. For simplicity's sake, the Ediacaran started around 635 million years ago and lasted for around 100 million years. That might sound like a long time ago, but bear in mind here that the very first life on Earth is estimated to date back to potentially 4.1 billion years ago, and even the earliest fungi were about 1.5 billion years ago. So, on the evolutionary timeline, that's still pretty young. Now, you might be wondering, what exactly are protists anyway? Well, this is a little tricky to define, as scientific understanding of this group is changing frequently. Not too long ago, in fact, the protists were considered their own taxonomic kingdom, the Protoctista, alongside the animal, fungi, and plant kingdoms. However, more recent research has led to that classification being largely abandoned. These days, they're mainly defined as an eukaryotic organism that doesn't fit into the plant, animal, or fungi kingdoms. There's a good chance you know of several, including red algae and kelp. In fact, protists are said to represent the most diverse group of eukaryotic organisms. By now, we've got a vague idea of where the first animal life evolved from, but that doesn't really get us much closer to identifying the world's first animal. Unfortunately, there are a couple of major issues here that make it very, very difficult to work out what the earliest ever animal was. Perhaps the biggest challenge is that the very earliest animals didn't have a skeletal structure as in modern species. This leads to a notable problem for the fossil record. Soft structures just degrade too quickly to fossilize well, meaning that these early animal fossils are very few and far between. Now, that's not to say we have nothing to work with, as there are some Ediacaran fossils of different species. However, this is where the second challenge comes in for identifying the earliest animal, telling them apart. Critically, distinguishing between early animal or plant fossils and protists is also very difficult, given the significant similarities between the three groups at the time. Even to this day, many people still assume algae and kelp are plants, so you can see why this becomes so tricky when all you've got to work with is an impression in a rock. And, of course, there's the third major challenge here, the rarity of fossils in general. Estimates suggest that anywhere up to 97% of species that have ever existed never fossilized. In other words, there's potentially as little as a 3% chance that a species would be recorded in the fossil record. Add in the number of species known by just a single fossil specimen, and the difficulty here gets even clearer. Namely, around 30% of invertebrates and 20% of insects are identified by just one specimen. So, even if the world's first animal did fossilize, there could be so few fossils out there that we just haven't found it yet. So, to summarize, while it's not impossible that the first ever animal may have fossilized, it's not guaranteed. Nevertheless, there are still several great contenders for the oldest animals in the fossil record. Moreover, we can also make informed predictions about what the first animal might have looked like. First of all, let's look at the fossil record we do know about. Recently discovered in 2022, the Aurora lumina Attenboroughi is perhaps the oldest known animal with a skeleton, dating back 560 million years ago. The Attenboroughi was a member of the Cnidaria phylum that includes modern invertebrates such as corals, jellyfish, and sea anemones. This creature is currently the earliest known predatory species. However, while it's one of the oldest known animal fossils, that does raise a notable problem. We know this isn't the first animal to evolve, as predation couldn't have evolved before there were herbivorous animals to prey upon. Another contender from around the same time period is Hautia quadriformis, with fossils also dating back to around 560 million years. This creature also fell into the Cnidaria phylum. This fossil specimen was particularly exciting due to being the first Ediacaran fossil to show evidence of muscle fibers. Perhaps a more well-known and widely accepted contender for one of the oldest fossil animals ever is the Dickinsonia, and this particular species has been found preserved in such good condition that molecules of cholesterol could be found. Cholesterol is exclusively made by animals in nature, providing proof that the Dickinsonia was undoubtedly an early animal. Still, even this creature has been dated to around 558 million years ago. That doesn't really narrow down our search for the very earliest animal. The same can also be said for the Icaria wariutia, which has been dated to around 555 million years ago. This species is especially interesting as the oldest known member of the Bilateria clade, which is characterized by having bilateral symmetry, i.e., a longitudinal body plan with symmetrical left and right sides. And with over 100 fossils, it was definitely a common species. Once again, though, this is a long shout from the oldest ever species. As well as direct fossils of the animals themselves, we can also draw upon trace fossils to help with identifying animal species. Trace fossils are effectively marks left in the sediment by biological activity, e.g., movement. These can often include tracks and burrows, and several such fossils from the Ediacaran have been found, some potentially dating even further back than the aforementioned fossils. Unfortunately, in addition to these confirmed fossils, there are several other contentious fossils that the scientific community just can't quite agree on. For example, Otavia antiqua sponge fossils have been dated to rocks between 760 million and 550 million years ago. Meanwhile, a mesh-like fossil has been found that would date back to around 890 million years ago. If accurate, that would be 300 million years older than our current specimens. Alas, these specimens are often disputed, and it's sometimes unclear whether they were genuine fossils or geologic formations that resemble sponge structures. We'll need to find more fossils and do a lot more research to say whether these are genuine or not. However, this is where the fossil record becomes a little lacking. As we mentioned earlier, it's estimated that the earliest animals came into being around 700 million years ago. If the earliest confirmed animal fossil is a 550 million-year-old sponge, that's a huge span of time we don't know about. That said, we can make predictions here. We've got evidence of species containing two Bilateria, Cnidaria, Ctenophora, and Porifera. However, one major group we're missing in the fossil record is the Placozoa, which are free-living marine invertebrates and classed as the simplest animals alive on Earth today. Molecular analysis has suggested that they are also among the most basal animals, making a distant ancestor of modern Placozoans an excellent contender for the first animal. However, we've only ever found one fossil of this species, dating back to the Middle Triassic. Unfortunately, measuring in at just 5 millimeters in diameter maximum, these tiny fossils aren't exactly easy to see. Plus, as we've mentioned earlier, such animals without a skeletal structure do not fossilize well. Given this, even if other fossils of Placozoans are out there somewhere, finding them feels like a needle in a haystack, let alone one from the dawn of animal life. Another strong contender for the first animal species, if not a Placozoan, is the sponge family. While we often consider sponges to be the most simple animals alive, they are still ironically more complex than Placozoans. Nevertheless, sponges are also considered a basal clade and are widely believed to have been the first group to have branched off from the animal evolutionary tree. And the fact we have older fossil evidence for their existence, such as this scanning electron microscope photo of a tiny 600 million-year-old sponge fossil. Plus, the closest known living relative of animals, the choanoflagellates, have a very similar cell structure and morphology to sponges, and likely evolved around the same time as the very first animals. While we've mainly been focused on the hypothetical thus far, we'd be remiss not to mention the Ermatazoan. In fact, the Ermitazoan has been described as the last common ancestor to all other animals. The problem? It's just a hypothetical. While we know that the Ermitazoan must have existed, we simply don't know what it was. However, we do know that the Ermitazoan likely would have had a couple of key characteristics, such as being a flagellate eukaryote, meaning it would have had a flagella, which is a whip-like structure often used for propulsion. In the end, there are numerous theories for what the world's first animal might have been, and realistically speaking, we probably won't ever find it, let alone prove definitively whether a species is the very first animal ever, even if we did. Nonetheless, we do at least know what it likely might have looked like, and there are several possible groups, namely the sponges and the placozoans, that seem especially good candidates. Whatever the case, it's always interesting to follow the science in this area, and who knows, maybe we'll find more fossils of ancient early animals that narrow things down further in the future. Thank you so much for joining me on today's dive into our ancient ancestors. Please don't forget to like, comment, and subscribe for more PaleoBrew videos soon.